So today we're going back into the world of graphing a bit. We've done some solving of systems where we found a point that they had in common. We've used algebra to find a common point. Did a little work yesterday with our applications, again, finding one specific answer for things. But sometimes there's more than one answer to something. Sometimes there's lots of answers to something. And so we're going to revisit inequalities, which we've done earlier this year. But now we're going to do that in a system way. So reminders for you up here at the top. When we're graphing these, if it's just the arrow, just the greater than or less than, we're going to use a dotted line for that. If it's or equal to, and I don't know why that doesn't have a line under it. Because I put the shading in there. Well, that was interesting of me. Okay. Shade above when it's greater than, shade below when it's less than, and then solid line with that. I wish I'd have reversed those, but that's okay. So step one, we're going to graph each inequality and shade lightly or use a color for each one. So I'm going to use red here. If at this point, okay, we are still having issues with graphing lines, you need to do one of a couple of things. You either need to go back to where some of the places were that we've done this and kind of watch some of those videos, or at this point you can grab a calculator. I'm not going to have the inequality arrow here, but I can type whatever this side is into my equation and pull up points. So let me show you both on this. Here is my y-intercept. Okay, that number is always going to be somewhere on the y-axis. So there's my first point for this one. What number's in front of x when I don't see one? 1. Okay, so for this one, my slope is 1 over 1. In other words, we're going to go up 1 and right 1. And you should have this earlier in your notes. And I'm going to keep going up 1 and right 1. Now, I'm not looking to see where the intersection point is this time. So if I get quite a few dots in here, I'm going to go ahead and I'm going to make my line. But, excuse me, remember, if your arrow doesn't have a line under it, we're going to be making a dashed or a dotted line. So we're not going to connect all the dots together. As far as the shading goes, if when I'm looking, if the arrow is pointing at my y, if it is less than, which this is, okay, we're going to shade below the line. Now don't do it real dark. If you're using colors, we're just going to put some lines in there for right now, so I know what I'm going to be looking for here in a bit. So I get that one done. If you're not comfortable with the graphing, reminder, you can type this part in and then just hit second graph. Let me come back up here into the normal numbers. And you can get 0, -2, 1, -1, 2, 0. And you can get the points to make your line. So you can do that either way with those. Okay, that's always going to be an option. My second inequality, there is my y-intercept. If my slope is not a fraction, I'm going to make it 1. So since my number on top is negative, that would be 2 down and 1 right. 2 down, 1. Again, we're not looking for the intersection point on these with the inequalities. Ooh, I got lucky. I went ahead and connected, and I started to look. I'm like, oh, nope, I'm okay. Again, if the line is underneath, if it's or equal to, that'll be a solid line. So I got lucky, it was solid, so I don't have to go back and fix that. And then since the arrow is eating my y, like it is up here, we're going to shade above the line. Now, maybe you'll look, you'll go, which side's above? Wherever you can see the top of the y-axis is going to be your above. So I do my above. The last step now is to find the place where the two sections intersect. So where I see both purple and red in my case, which is in here. And I'm going to make that darker, or you could outline it deeply with your pen or your pencil. But just make sure it's very visible to see that that's the area we're talking about. And that area, any point that I would use in there, if I plugged it in for x and y, it would be true. So there's lots of right answers this time. But that's how we do these systems of inequalities as we do these. And yes, there are even kind of special cases for these, even though we'll look at some more normal ones when we get into the practice. So I get here. If I need to, and I'm going to because it's been a while, just a second here. Okay, this is where doing my notes and keeping them updated helps me, because this is back on the front page of the notes, and I've got the x equals and the y equals and how the lines go up and down or side to side and how to do that. So if I needed those, I could have it, but we'll just discuss them back here. Y equals is always going to be a horizontal line. So I go on the y-axis to where y is 3. I put a dot. Horizontal line, but be careful. Okay, no line underneath, it's dotted or dashed. Is that really important, Hardy? It is. You're telling the person looking at this if that number is included or not. Whenever it's x equals, I'm going to go to where x is -2. Again, since the line is underneath, that's going to be solid. Oh, I didn't shade on the first one. So let's go back to shading here. Y is being eaten by the arrow. We're going to shade above. So we're like, all right. Now this is the one that's interesting though. Right? Okay, x. The arrow is pointing at x. Supposing when the arrow is pointing, it's shade below. You're like, Hardy, I can't do below. Like it's right or it's left. So let's update this up here a little bit. Okay, if it's just x and a number, and it's greater than, we're going to shade to the right because that's where the bigger numbers are for x. If x is less than, if the arrow is pointing towards x, we're going to shade to the left because that's where the numbers for x become less than. And just like we did on example 1, once I do that, I'm going to find the area where I'm seeing both colors that I have so far. And that's going to be my solution section that I'm looking for. They can be real big, they can be little, it just kind of depends. Okay, so as far as the examples go, That's what we got rolling for today. So again, don't put them away, just keep them close. We may need to reference. For those of you that weren't here yesterday, we renumbered our packets because, again, there was a printing error. So if your packet is not numbered yet from the beginning, flip until you see the 6.5 Systems of Inequalities on a left-hand side of your page. That's where you're going to want to be for today because we're going to be practicing on pages 3 and 4 today. And so I start to look at these and I'm like, okay, might as well do the first one. That's a good place to start. Excuse me. So I look and I'm like, okay, first one. Let me get my colors going here. X is less than 3. Okay, I got this. There's where X is 3. We just got done seeing that X is an up and down arrow. Is my line going to be dotted or solid? Dotted because there's no line underneath. And when X is less than, we're going to shade to the left. Get that in. My other equation, my other inequality is more traditional. I'm going to put that first dot on -1. And then I'm going to go up 1 and right 2. As long as you've got at least 3 dots, you should be good. Again, I take a quick look at my arrow to see if I wonder what the answer is. If my line should be dotted or solid. Again, we're going to be dotted or dashed, as we may say. But this time the arrow's eating Y. Arrow's eating Y, we shade above. So, get those in. And once we've got that, okay, down here is just red, I don't want that. Over here is just purple, I don't want that. I want this area in here that gets me the value, but now there's an additional question now. Is 1, 1 a solution? So here's how I answer that. If I go on my graph and I go to 1 and I go up to 1, this is why I don't want to shade real deeply with whatever colors I'm using because I want to be able to see the point that I'm looking for. If I plot the point 1, 1 and it's in my shaded, it's in my colored area, the answer is yes. If it would have said like, is 2, -2 a solution, and I put my dot down here and that's not where I colored in, I just put no. That's all I got to do for that part. If it's in the shaded area, we go yes. Not in the shaded area, we say no. Let's see here. Let's play with one more. Because then I want to look over here. Ooh, oh wait, no, let's come over here. I'm glad I saw this. Okay. Let's do number 7, because I don't want people to get thrown off by this. And then we'll do a little review here too. Okay, here's our problem over here. You've got to have y equals by itself. And I don't with these. We got to rearrange the equations first. So, on this first inequality, I got 3y here on the left right now, but I want y by itself. What's the opposite of multiplying by 3? Divide. I was going to say, we're still here. 1 divided by 3 is not 3, it's 1/3. So I divide everything by 3. Now my y is alone. Now I'm good to go. I'll show the calculator on this one again too. I'm going to go up 1 and right 3. Get at least my 3 dots. There's no line underneath my arrow. So we're staying dotted. Arrow is eating y. We're shading above. And then I go to look at my next one. I'm in the same dilemma. I need y by itself on this side, but I'm adding x to it. What's the opposite? We're here still. I was just telling the people who'll be watching later that we're here still, like the video's still working. I was going to say, it's so much easier to be involved with stuff when you put yourself into it instead of just sitting back. So the opposite of add is to subtract. So I'm going to minus the 1x from each side, remembering that when we're getting these in y equals, the x part always goes first after the arrow. Don't write -2 minus 1x. You're going to get your y-intercept flipped, and I'd forgotten to show that last one on the calculator. I'll do it on this one. So here, there's my -2, y-intercept for the first part. We're going to go down 1 and right 1. So again, just prove a point. No pun intended. There's 0, -2. There's 1, -3. There's 2, -4. So I can get everything I need off the calculator in y equals. Dotted line, because we're not or equal to. Arrow's eating y. We're going above. So this one isn't really any different from the ones we've been doing. This is all red. I don't want that. This is only purple. I don't want that. And I find my solution. So the calculator to get your lines, knowing slope-intercept to get your lines, and then using the note sheet to help with my shading. And then just a couple from yesterday to kind of remind ourselves and kind of go back through some things, make sure we don't forget. Now notice, and instructions are important. Set up a system of inequalities, which means we're using arrows for each situation. Do not solve. So it's like yesterday, but with arrows. So let's chat about a couple of things. We're going to put a couple of notes in on this one. When we see the word at least, we want to be greater than. Okay, so I'm even going to put a little y in here just so we make sure we're good. Because I want more than that. When I see not more than, That's when I want to be less. Okay? And those words can change slightly. But for the most part, they won't. And so when I'm doing these, I start to look and I'm like, okay, Kelly makes $7, man, this must be old, $7 an hour working at the grocery store and $10 an hour delivering newspapers. She cannot work more than 20 hours per week. She wants to earn at least $90 per week. So we're going to need an hours inequality and we're going to need a money inequality. This is kind of like, let me pull my notes out. This is kind of like what we were doing yesterday, probably more with this one, with the video games and DVDs, where I look and I'm like, okay, so I'm working at the grocery store and I'm delivering newspapers. So I'm working at the grocery store, oops, wrong color. My grocery store hours and my newspaper hours cannot be more than 20, have to be less than or equal to 20 hours a week. So if I know how many hours I worked at the grocery store and how many I worked delivering newspapers, I got to make sure it stays under 20. I'm not sure why, but it is what it is. The money part, I go looking for everything with a dollar sign. I get $7 an hour at the grocery store, so the 7 goes with the G. I get $10 an hour with the newspaper, so the 10 goes with the N. She wants to make at least greater than or equal to $90 per week. You're done. That's it. So it's the same as what we were doing yesterday, except with a little bit of a twist. Let's play with one more of those, because that's kind of new. Let's play with 11. It looks like a school thing. Harlan's putting on a freshman play. Okay. There's at most 300 seats in the auditorium. Adult tickets are $5. Student tickets are $2. Harlan wants to make at least $500. So it looks like we got seats, and once again, we got money. Two different things. So I start to look, okay, what type of seats are there? I got adult seats and student seats, not the number 5, the letter S. At most, no more than, so we got to have less than or equal to 300 seats. No more than 300 butts and seats. Then comes the money going with it. $5 for adults. They go together. $2 for students. They go together. We want to make at least, at a minimum, greater than or equal to $500. So that's how the setup is going to work on those other two. And as I've been saying for the past couple of days, and we'll say it nonstop for the rest of the school year, if you practice, it makes quizzes easier, I promise. Okay, if you're doing the notes and keeping them and not losing them, it will help on the quiz. It will. So I'm hoping you do that. Try these out. The answers are online. I got them up front here too. So if you want to check out, please do as you go. If you run into questions,